Now, I just had to see how much difference the handheld pendulum, the period of a handheld pendulum, how much difference there was between a handheld pendulum and a well-anchored pendulum. So the data we had here was for a well-anchored pendulum. I took data for the handheld pendulum. Then I'll talk about that in a minute, but right now I want to just back up and tell you what we've got for the original data for the anchored pendulum, and a couple of things that you need to understand about this data. Okay, we calculated the mean and standard deviation of these quantities. We took half the mean because this was for each of these intervals was for 2 cycles. We took half the mean to get the mean for 1 cycle, half the standard deviation. We said, okay, we're comfortable saying this is the period is 1.96 plus or minus 0.04 seconds. Now we can actually, for the amount of data that we took here, use what's called the variation of the mean, the standard deviation of the mean, and reduce that 0.04 seconds to something around 0.01 second. But the other thing is that this is what we would do if these were independent measures of the period. But they aren't independent, they're sequential. This one immediately followed this one immediately followed this one, and so forth, so that the sum of all these, and how many of them are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16. Okay? So we really measured 32 alternate cycles, and that means that we measured this for a period of about 60 seconds, in fact a little more than 60 seconds, because we measured 32 almost 2-second cycles. This went on for somewhat 63 seconds or so, and the total uncertainty in the total of these times is on the order of a standard deviation or 2. So really, we expect that our standard deviation being 0.077 seconds for the alternate cycles, it's unlikely that our total is off by more than about twice that standard deviation. Because remember how a normal curve works. Within 2 standard deviations, you've got 96% of the curve. So we're kind of like 90% certain, if indeed these measurements are normal, if our timings follow a normal distribution around a mean, we're really pretty safe saying that we're probably within 0.15 seconds of the right time for the entire minute, or for the entire 30 cycles. Now, if we're only off by 0.15 seconds for 30 cycles, that comes out to only 0.005 seconds per cycle. So our plus or minus is more like 0.005 seconds than 0.04 seconds. And we can do similar calculations for the data for the other 2 pendulum lengths, obtaining estimates of plus or minus 0.003 second per cycle uncertainty in the average duration of a cycle for the 51 centimeter pendulum, at a plus or minus 0.002 second per cycle uncertainty for the 25.8 centimeter pendulum. So those are important distinctions, and hopefully you understand what I'm saying. If these were independent timings, not sequential timings, we'd be stuck with something like this. Because that means, you try to time from the middle of one cycle to the middle of another, and then several seconds later, you try to do it again, and you keep trying to do it, but without actually timing the intervening time between those cycles, all the cycles that occur between the 2 cycles that you time. So if these are independent timings, we're stuck here, but we can actually reduce this 0.04 second uncertainty using the standard deviation of the means, which I'm not going to talk about. That's just something that you'll encounter. That's you can look it up if you like. But the bottom line is these purple uncertainties are really kind of the uncertainties that we think we have in our mean results. So this looks like it's about 1.96 seconds plus or minus 0.005 seconds. This looks like it's 1.43 plus or minus 0.03 seconds, and so forth. Now, we'll move on. And I have slightly more refined figures for this in the document. But now we'll talk about what kind of differences we think we might have seen with a handheld pendulum, because that's kind of an interesting experiment that can be done very easily, and for about a quarter's worth of material and an hour's worth of data taking and analysis.